All right, guys, so continuing on with the last little part of the test review. So we just did number 9, so I'm going to go ahead and do number 10. So this says write a natural logarithm with a translation right 2 units. Okay, so natural log is ln, right? Right 2, so in parentheses, go right 2. Remember, it's the opposite. So normally you put, normally you'd think x plus 2 for right, but we really put x minus 2 for right. And then we're going to go down 6, so that's minus 6 afterwards. And then a reflection, okay, so reflection over the y-axis is where it gets a little bit tricky. So remember, when you do a reflection over the y-axis, you need a negative inside with x, but you have to put parentheses around what was already there. Because the negative applies to everything, like everything is reflecting, so you have to put a negative and then parentheses. So you could leave it like that, or most of the time people actually distribute that negative in, and so it would actually look like negative x plus 2 minus 6. And so a lot of times people, when like they're given a problem like this and they say, what is the transformations? A lot of people think that's left 2, but that's not. That still means right 2 because of the negative. Because of the negative, that really means x minus 2, which is a right 2. Okay, so just be careful. We learned that last unit, but people made big mistakes on that. So, okay. This one says the domain of a logarithmic function is 8 to infinity. What is the domain and range of the inverse function? So remember, for inverse, domain and range, everything, x-intercept, y-intercept, they all flip, right? So if it's telling me the domain is 8 to infinity, that means for the other one, the range would be 8 to infinity, okay? And then the domain, well, hopefully you guys remember, the other one is always negative infinity to positive infinity. So for all, because this is, the inverse would be an exponential function. For all exponential functions, the domain is negative infinity to positive infinity. So anyway, hopefully that made sense. All right, this one says, what is the domain, range, and end behavior of this? So whenever I have a problem like this, I like to kind of just sketch out what a graph would look like. So remember, for exponential, you have this as the asymptote. So we have an asymptote down here at negative 6. And then if we think about it, normally an exponential goes up, like starts over here and goes up. But this one, because of this negative, it's actually going to go down like that. So that's what that one would look like. Okay, so the domain for this one, domain for all exponentials is negative infinity to positive infinity. We just talked about that in the last problem. So that should be easy. It goes left and it goes right. So negative infinity to positive infinity. The range, however, is a little different. So this one is going down, right? This is going down. So it's going to go to negative infinity. But then the highest up it goes is negative 6. So I didn't even mention for these, but remember, we use parentheses instead of brackets because we're not actually touching negative 6 as an asymptote, right? So this goes down to negative infinity and then up to negative 6. All right, and then last, end behavior. So remember, end behavior has like the setup like this. Sorry, the bell's ringing. But because, let me pause this actually, hold on. Okay, sorry guys, so the bell was ringing, so I paused it, but anyway, okay, back. So this is how you set up end behavior as x approaches, f of x approaches. So anyway, so the first part, the x part, you kind of like match the domain essentially, because the x values go from negative infinity to positive infinity. So we'll just kind of fill that part in, kind of follows the domain there. And then the other part, I like to think about it as left and right. Okay, so for the left side of the graph, it's not actually going up or down, it's stopping, right? This left side of the graph here is stopping at negative 6. So we write negative 6. But the right side of the graph, this other side of the graph, is going down. So we're going to put negative infinity because it's going down. Okay? All right, so that's that one. All right, so the next one is a log graph. So asking domain, range, and end behavior. So I'm going to sketch out what the graph looks like. So remember, for logs, you look inside it because it has a vertical asymptote. So the vertical asymptote would be here at negative 4. Okay, and then this one, once again, normally logs go like this, but because there's a negative in the front, it's going to start up here and go down that way. Okay? but still, let me kind of redraw that. It looks kind of bad. So it starts up and then goes down like that. Okay, something like that. Okay, all right, so then for the domain for this one, the domain's a little bit different because it doesn't actually go to these negative left values here. So we have to say -4, because that's the furthest left it goes, but then it goes to the right, so to infinity. Hopefully that makes sense. But the range this time, this is going down, this is going up, so the range is -infinity to +infinity. So it kind of flip-flops there, right, for logs and exponentials. All right, and then end behavior, remember you set it up like this. And remember, your x's kind of follow the domain because the x values this time don't go to -infinity. They go to -4 and then to infinity. So we have to kind of copy the domain there for the x's. But then I like to, like I said, think of this as left and right. The left side of the graph is going up, so I'm going to put +infinity. And then the right side of the graph is going down, so I'm going to put -infinity. Okay? All right, this one says, this is an easy one. This says, what is the asymptote? So remember, you just look inside for logs for the asymptote. None of the other numbers matter, so it's x equals -2. And remember, you always switch it for logs, like the x value switches. You lie to your x's. Okay, and then for exponentials, remember, you look afterwards, and that one's a y equals -4. So a trick I tell my kids to remember, so exponential, if you kind of extend out an e, then that has a horizontal asymptote. And I mean, that sounds kind of confusing, but horizontal lines can move up and down. They can go up, they can go down, and so you look up and down and look at that number. Versus log starts with an L. Well, that looks like a vertical line, doesn't it, an L? And so vertical lines can go left and right. And so that's why you look inside for logs. All right, and then the last section here, it says match each graph with its correct equation. So really what I do for this is I figure out first, is it a log graph or exponential graph? And that's based mainly off the asymptote. So if it has a vertical asymptote, like I said, log starts with an L, so it has a vertical asymptote, exponential has an E, has a horizontal asymptote. So let's do the log ones first because this one has a vertical asymptote, the very first one. So that's a log graph, and then this one down here, the first and last one are log graphs. So they'll be either A or C. And then from there, I just base it on, honestly, the asymptote. And so remember, for logs, you look inside. So this has an asymptote of x equals 1. And so the one that has an asymptote of x equals 1 is this one, the first one. And then this one has asymptote at x equals -3, and that's this one here, right? All right, and then the other two are exponentials, so those have horizontal asymptotes. And remember, for horizontal asymptotes, you look out here. So this has y equals -3, and this has y equals 1. And then this one also has a big clue here with this negative. For the negative, that right away is going to tell you the graph needs to be going down. So that's going to be this one here, right, D. That's going down, but you can also see the asymptote is here at 1, and versus the other one, it's down at -3, so that one's B. Okay, so that is the whole test review, so good luck on your test.